Hi, everyone. My name is Adam. I'm a PGY4 from the University of Colorado. Happy to be here, so thanks. So we did a project on developing and implementing an image registration and fusion workshop for radiation oncology trainees. So a little bit of background, our field does rely heavily on image registration for the completion of daily tasks. Quality registrations are necessary for treatment safety and efficacy, including during contouring and treatment planning, which is really what we focused on with this project, but also definitely setting up image-guided treatments as well. Currently, there's no standard education recommended for trainees regarding this, so our goal was to help kind of fill these educational gaps. So our curriculum consisted of a hands-on portion, which was assignments created for participants to practice image registration, so to help them create image registrations. So how we did that was we anonymized real patient cases to create these assignments. They were created for the 5 major disease sites. I'll discuss how we got those a little bit later. With each assignment, participants were given fusion request instructions. So for example, for the prostate case, they were given instructions to fuse to the fiducial markers. And then next we had a lecture-based portion. So it was 2 hours of lecture led by a resident and medical physicist, which covered various topics, including image registration algorithms, evaluating registration quality, understanding workflow of image registration. We also performed an example of image registration in fusion, and disease site-specific anatomical and technical considerations. So we chose the 5 major disease sites based on a report which we created of all image registrations which were requested for treatment planning purposes within a 4-month period at our institution. So there was 90 registrations in the report total, which were all broken down by disease site, as you can see in the pie chart there. So CNS, head and neck, pelvis, prostate, and spine disease sites made up about 80% of the fusions. So we chose to focus on those sites. Evaluation. So the qualitative evaluation we did consisted of a survey each participant completed before and after the entire workshop. So the questions were evaluating participant confidence with creation, evaluation, and understanding of image registrations. We also had a quantitative evaluation where we compared participant pre- and post-workshop assignments and measured deviations of participant completed assignments against a gold standard registration, which was actually a previously clinically approved and utilized registration for each case. We also measured each participant assignment deviations from the group median to measure group similarity for the assignments. And then all the analysis were done with the Wilcoxon rank sum test. So here are the results of the survey. So there were 7 total participants, 6 total questions in the survey. And you can see the pre-workshop on the left revealed many participants were not confident, which is that red color regarding image registrations. And then post-workshop on the right, there was no longer any not confident, mostly quite confident, extremely confident. For each question, there was a significant increase in confidence noted as well. The quantitative results, so in the head and neck subgroup, was the only significant result that we noted. Before the workshop, the median difference between participant and gold standard registration was 10.15 millimeters, which did decrease to 5.64 millimeters after the workshop. Again, no significant differences were noted in any of the other disease sites. So this is a violin plot, which is really showing the pre-workshop in yellow, post in purple. On the y-axis, what we're looking at is the magnitude of translational differences between participant and that gold standard previously approved fusion. The width of each violin plot corresponds to the frequency of data points around a certain value. So you can see that before the workshop, there were several outlier data points, outlier assignments, which increased the total range to about 64.5 millimeters. And then after the workshop, these outliers did not exist. All the fusions were within 1 centimeter of that gold standard fusion. This is a similar plot that we're looking at, but instead of comparing it to a gold standard, these are compared to actually a group median. And so you can see, again, there was an increase in group similarity after the workshop was completed, so decreasing those outliers. The range was over 7 centimeters pre-workshop, and then post-workshop again to all within 1 centimeter. So discussion, our image registration fusion curriculum achieved its goal of improving participant confidence in evaluating, creating, and understanding registrations, and also decreased the magnitude of outliers in participant fusions. Major limitations, obviously, this is a very small single institution study, and the subjective nature of image registration does make it difficult to evaluate quantitatively. There is no true gold standard fusion for any specific case. And that's it.